Thank you, Hugo. Thank you, everyone. And yes, we are going to talk about how we can consume Microsoft API from both powered ACEs for Microsoft Viva connections. We have already covered a couple of months ago how to create a bot powered ACE or adaptive card extension for Viva in a previous community call. Now, today, we want to dig into something close to the real life experience and to real life solutions. So just as a reminder, the bot-powered ACEs are a fresh new technology introduced and released by Microsoft really recently, and which can be used to create on the server side using the bot framework, whether with C# or Node.js, an adaptive card extension to extend the Microsoft Viva Connection dashboard. Now, with this new development model, for example, you can use a C# bot framework-based solution to render on the server side the output that will be then shown in the UI of the Viva Connection dashboard. And this is really useful whenever you want to have really private algorithms or you want to consume APIs with secret keys or stuff like that, and you want to keep your code safe and secured on the server side rather than having client-side code, as well as whenever you want to reuse already existing code, because, for example, you might have already implemented a bot for Teams, just to make an example, and you want to reuse the same logic also to provide the UI components of a Viva Connection. But what is really important and interesting to know is that you can also use and consume the Microsoft Graph or any third-party APIs in a secure way, relying on open authorization and Azure Entra ID. So that's what I'm going to cover in this demo. And first of all, I will show you the actual implementation, so how it looks from an end user perspective and from an implementation point of view. And then we will briefly come back to the slide deck to have some additional insights about this topic. So first of all, let me switch to my browser in my demo environment. And this is the demo that I just released, as you can see, just yesterday in the sample solution gallery. You can find it in the home page just for a while, because we have so many new demos every single day that most likely tomorrow will be already in the second page, which is great because all the community is contributing heavily to the sample gallery. But this is the demo, and then you will find the link in my slide deck. The demo has been built based on this technical article that you can find on learnmicrosoft.com, where you can find a step-by-step guidance about how to secure the communication between a bot-powered ACE and Microsoft Graph or any other backend API. And now let's have a look at the user experience. Here I am in the Viva Connection dashboard. Let me refresh the page just for the sake of having fresh content. We go to the Viva Connection here, and you can see here I have a couple of adaptive cards. Those two adaptive cards are server-side rendered based on a backend bot. So you see I have a sign-in button. I can click on the sign-in button. I will be brought to a pop-up dialog provided by the bot framework, which will give me a code which is usually called the magic code for authentication. I can copy the value of the magic code. I can come back to the adaptive card and provide the actual value of the magic code through this UI. And once I've done that, I will be authenticated and able to use the advanced functionalities of my adaptive card. Here, for example, I can see the emails that I have in my inbox, as you can see right here with this popping up UI, which is called Quick View in the adaptive card extensions world. Now, what is important to notice is that now this flow with the magic code and stuff like that is something that you will have whenever you don't have support for cookies or whenever you are using as an authentication provider that is not based on Entra ID. While pretty soon, it will be possible to have an automatic handling of this magic code. So basically, the end user will simply click on the sign-in button, and automatically they will be signed in into the adaptive card extension. So now let's see what's happening under the cover. As I said, we have already seen a couple of months ago that in in order to create a bot-powered adaptive card extension, we need to have an Azure bot configured. So let me switch to my Azure environment, if I can find it, and here it is. And this is an Azure bot that I created for this specific demo. Once you create the Azure bot, in the configuration of the Azure bot, under the Microsoft App ID section, you have this Manage Password link, which allows you to open the actual settings of the application registered in Entra ID to support your bot. In this application, aside from taking care and note of the application ID, tenant ID, eventually of a client secret if you need it for security reasons, you also need to configure in the API permissions the permissions that your bot will need to consume the actual API you want to leverage. So here I'm reading the email messages in the inbox of the user, and as such, I granted the mail.read permission, delegated permission, for my user. Why did I stress the delegated word? Because now, here, in this context, we are working under the security context of the currently connected user. So the bot will be able to consume Microsoft Graph on behalf of the user who is consuming, who is browsing the Viva Connection dashboard. So first bullet, or first task to accomplish, give proper permissions for Microsoft Graph or for any third-party API that you want to consume in the application backing the bot. Then, just as a reminder, when you create a bot for Teams or for Viva Connection bot-powered ACEs, you also have to configure an application unique URI, as well as a custom permission scope, which is precisely this one, access underscore as underscore user. And you have to allow the Teams client, both the desktop, web, and the mobile one, to access your application with this specific permission scope. So once you have done that from an application configuration perspective, you can go back to your bot. And still in the configuration section, you have this area where you can configure one or more open authorization connection settings. By doing that, whenever you click on the Add or Off connection settings, you have to provide a name and you have to choose one of the many identity providers which are supported by the bot framework. As you can see, there are a lot of them. And if you want to use Entra ID, well, indeed, Azure Active Directory v2 will be your target, which is exactly what I have configured right here when I created my secure bot ACE Entra ID connection settings. By configuring this item, I simply provided here, selected the service provider. I provided the client ID of my application and the client secret that you saw it was configured before. I specified, and you have to do that, the token exchange URL. My application in Entra is a multi-tenant one, so here I use common, followed by / and the URL of the token exchange URL. As the tenant ID, I again specify common because this one is a multi-tenant bot, or it might be that you want to have a single tenant one and you will specify just the ID of the target tenant, and then the permissions that you want to get when you will use these connection settings in order to retrieve an access token on behalf of the user. And here I want to read who the user is and what the email messages are in the inbox of the user. So user.read space mail.read, and you can provide as many scopes as you need. Okay, so once you've done that, it's now time to have a quick look at the code base. So let me switch to Visual Studio. And this is my bot-powered ACE running in my Visual Studio. Again, for the basics about building bot-powered ACEs, please have a look to the other demo that I made a couple of months ago. But here in the constructor of this bot-powered ACE, I'm creating, for example, the card view that you saw to sign in. So basically, this one or this one on the right side for the other instance. And this is a card view of type sign-in card view parameters. So with this factory method, you create a card view to sign in the user, and you have to specify a card button component, which will be the one implementing and providing the complete sign-in logic, which is mandatory, but it will be used just for other identity provider other than Entra ID. Then you have to specify for future usage the card view type of type sign-in. And then you can have as many card views and quick views as you like in the implementation of your actual bot-powered ACE. In my scenario, I decided that when the user will click on the complete sign-in button, I will show a quick view. which is defined right here. And this quick view, which is completely customizable, you can build it as you want, will have just the text box to collect the magic code and a button to trigger the actual login based on the magic code. Now, what happens when the user will click on the sign-in button and then get back the magic code and click on the complete sign-in logic? Well, first of all, if the user will click on the card and we'll go through the automatic flow, we will simply look for a magic code property which will be automatically injected in the request that will go to the both powered ACE. We retrieve the value of the magic code, and using a backend service provided by the bot framework, here in the get user token, we get, in the current context, the user token client service. We retrieve the user token of the user, specifying the connection name, which is the name we have right here, the name of our connection. By doing that, under the cover, there will be a lot of plumbing, making it possible for me to get back an access token that I can use to do the actual consumption of the Microsoft Graph. If I don't have a user, it means that I need to authenticate, and as such, I will show the sign-in card view. Okay. If the user will provide the magic code manually, I will have to handle that magic code in the task handle action of my bot powered ACE. So again, I will get in the action parameter, so as an input for my action, the magic code provided by the user. And one more time, using the get authenticated user, I will do the same as before. So I will get a token for the user, providing the magic code, the context, and eventually the cancellation token. Once I have the token, no matter what, if I've got it using the automatic flow or the manual flow for any other identity provider, I then can use the access token to consume Microsoft Graph. And so, for example, to get the list of email of the user, I created a method which will get the user token, and using the Microsoft Graph SDK, will simply build an instance of the SDK, and using the Graph SDK, will construct the request to get the list of messages, the top N messages in the inbox of the user. So the consumption of Graph by itself is really trivial. But what is really important is that you need to rely on the get user token through the user token client, which will also provide you the capability to sign out the user. Still with the same service, you can also force a sign out of the user. Now, briefly and quickly back to the slide deck, just to give you a couple of hints, and then I'm done. This is the recap of the steps, just for your convenience. And of course, you will have, as we already saw in the previous demo, you will need to define a manifest for your application. But things to keep into account: the security context is shared across the same instances of the same card. So if you will have multiple instances of the same card, once you log in one of them, you will be logged in all of them. On the contrary, if you have different cards of different flavor, you have to sign in every single card. So you will have to do the sign-in flow for every single different kind of card. The same applies for the sign out. So if you sign out from one instance of a card, all of the other cards of the same type will be signed out automatically. You need to keep this into account because it will slightly change the user experience, maybe compared to what you are used to do in a regular solution. That said, here you have the link to the sample that I showed you, and you also have a link to the initial article about how to build a bot-powered ACE, and a second article, which is the one I've just covered in this demo, where you can see how to build step-by-step a secured bot-powered ACE with authentication and authorization in place. Thank you, everyone, and back to you, Hugo.